Hello, welcome to ENS Integration Workshop for ACE Global Hackathon September 2021. And today I'm going to talk about three topics. First, I quickly go through kind of basic of how to do the ENS integration, and then I spend the rest of the time going deeper into more core of ENS. It's called one is called Resolver, and another one is called Registrar. And I just show it as a kind of teaser that I'll explain what this is as I go through. And for the relevance to the hackathon, in the past we used to give small, like $100 worth of prize to many integrations for the basic one, and this time we want to do encourage you to kind of discover the power of ENS and take more advantage of it. So we'll not give small prizes, but rather we're gonna give bigger prize, pool of like $3,000 worth of ETH or USDC. We don't know how many the winner is going to be, but rather than giving to like 10 prizes, we probably gonna give like somewhere between like 3 to 5. And in addition to that, we are planning to have a ENS workshop right after the finale of the ETH Global. And so for some of the winners, we'd like you to invite to do a bit of a kind of pitch to the community, and we are kind of thinking about a kind of community voting so that you can earn extra prize. Okay, and I will go through lots of material, but majority of stuff you should be able to find in our doc page called docs.ens. Or if some of the information is actually too new, so if it's not in, you can just ask me a question on Discord. I'm relatively active there. Okay, so ENS Integration 101. So one thing about great thing about ENS integration is quite likely you don't have to install any new things. That many client library already have ENS, some of the ENS integration. The one we also use quite a lot is called ETHOS.js, which actually the author of ETHOS.js, Rick Moo, is now part of the ENS team. So it has a quite tight integration. But most of the JS libraries, especially ETHOS.js, they do good support for kind of read-only operation or kind of looking up ENS. But when it comes to writing, setting record, support could be limited. In that case, you could use our ENS official library called ENS.js, or if you go to the doc, there's information about how actually most of our smart contract itself is an NPM package, so you can actually just include that NPM package on your either front end, or you can import in your Solidity contract. So what is ENS? Actually, I don't think I introduced myself, and in kind of Ethereum world, my identity is this hexadecimal 0x5A3A4 blah blah blah. And the ENS provides a kind of human, readable, friendly ways to associate my Ethereum kind of wallet address to this name. So if you go to, for example, MetaMask or Etherscan, and if you look up matoken.is, it should resolve to these Ethereum address so that you can send the crypto address, or you can receive. But it's just going a bit beyond that. Initially, Nick Johnson, who created Ethereum name service, he started kind of putting like his Nick D Johnson.is into his Twitter profile, but like it kind of started blowing up when Vitalik put his Vitalik.is into his Twitter profile, and now so many kind of Ethereum so-called influencers now put like their ETH name, and also there's lots of people, thanks to the NFT's popularity, many people outside of crypto world start getting into the Ethereum, and we have lots of so-called ENS fairies. They kind of have a like famous celebrity's name, and they try to give it to you. So to these people so that they can be part of this Ethereum community. So it's ENS becoming just more than the convenient utility, but it's almost becoming your identity on the Web3 world. So we started calling as a like your Web3 username. That's kind of our new catchphrase. And so to do that, again, it's quite easy. If you so the forward lookup, if you give me the name, I return your address. That's just done by ENS, something like ENS get address if you use Web3.js. And the reverse is that, so for example, if you log into, for example, Uniswap or OpenSea, and if you connect wallet to their site, they immediately recognize your ENS name and they show it to you if you set this ENS name on our manager. This doesn't get done automatically when you register, so you have to do it manually. But once you do that, you can start seeing. And now I think EtherScan does actually show the transaction history with ENS, so you can actually see who, like, transaction went from who to who a lot easier way. And to do that, again, it's just almost like one-liner. This is example uses library called Ether.js, and here it says provider.lookup address that returns the ENS name. One important thing is you can, when you set the address to name, you can actually set any names. Like you don't have to put, well, technically I can put vitalik.is to points to my 0x5A address. Then people can easily fake it. So what that developer should do is we should cross-check both reverse lookup and forward lookup, and both pointing to each other. That if you use library like Ether.js, it does that inside, so you don't have to worry about it. But if you, in case you use your own way, you might want you have to do it. Okay, so second is ENS Resolver, and let me just show you this basic architecture of ENS. ENS is just like any other dApp, it's smart contract. It's one of the oldest smart contract in production. We launched back in 2017, and its basic is very simple. It's just basically a gigantic phone book where you have a ENS name and you have a full list of ENS name. What's interesting is it has something called resolver, and let me show you the flow that when user look up, for example, for lookup, you first connect to this ENS registry to say, hey, I want to know resolve who.is. And registry doesn't return the Ethereum address of who, but instead it returns something called resolver contract address. And the client actually asks to this resolver, what's the address of this who.is person? Then resolver is in charge of returning it. So underneath, end user don't realize, but underneath, basically JS client is calling the ENS smart contract twice. And why we do that is because it makes basically resolver logic extensible and upgradable. We have a default one called public resolver, which everybody mostly uses, and we set it when you register. But you can actually set your own resolver and extend more features. And currently, most people know ENS as resolving Ethereum address, but underneath you can actually set other things like content hash, which you generate for IPFS, or now we have support for Arweave, and you can set these. Then you can basically, even in the IPFS side, you can resolve with ENS name rather than their very long content ID. So this is how it looks like. For example, this case in the address, we have now so-called Multicoin support. So not just ETH, you have BTC, LTC, over 200 addresses. And the important thing is the wallet also has to support the multicoins, but once it's supported, sorry, I think I got random pop-up. I got close. Yeah, once, for example, a Trust wallet, you can basically send BTC to Brantley.is if you want to. And doing that is, again, it's quite simple. That now you know what Resolver is, right? So like if you send me the BTC, give me BTC address of this Resolver.is, you just do it like this. Depending on this case, we are using ENS.js, so syntax is slightly different, but all the other libraries is kind of. I think this Multicoin is actually relatively new. So ESA.js does support, but some other libraries may not support multicoins. And updating record is usually like set address or set content hash. And in this case, I put setting text, where you put a key as text and a record, a value as test record. And we really want to promote the use of this text record. And one use case is avatar. So I think a couple weeks ago, well, actually almost a month ago, Zappa announced a new feature where you can set your NFT as an avatar, which is great, right? But the problem is like it's kind of on their own silo, so that information is not really shared anywhere. So we came up like kind of talked about a new specification that Nick Johnson, who is the creator of ENS, drafted ENS avatar field format specification, which is not finalized yet, so it's relatively new. But like we want to kind of start encouraging user not to put avatar field initially. Like we just created to put like JPEG URL, but we wanted to allow people to set text record. Text record itself doesn't have any validation. You can put anything. So it comes down to the specification that each DApp agreed to resolve in a certain way. And with using that kind of protocol, I did actually added a small feature in the text record that if it says avatar, if you specify, so this is an example of the specification that EIP 155 and then 1 is a chain ID, and /ERC721, you could also put 1155, then colon contract address / token ID. Then you, with this information, is enough to fetch the image URL from the smart contract. So it displays, this is my people pleaser NFT image, which I have. And one thing I added is I can also verify that I own this smart contract. I can't really verify that this could be like copy and paste it to different contracts. So I can't say this is a canonical. All I'm saying here is I own this specific contract, and in this case, it puts a link to OpenSea, so you can actually verify that this contract address is it really people pleaser's contract address or punk address. So that at least like it allows you to verify on your own. And if you try to do that by yourself, it's going to be a bit like this. So first on the line 2, you do provider.resolve.name, and then you do vitalik.is or matoku.is. Important thing is ownership, or what I shouldn't be the, for example, matoku.is is an NFT itself, so it has an owner information, but owner should be point to the address ENS resolved to using for lookup, because something like subdomains doesn't have the notion of like a token ownership, whereas this resolver name is a consistent ways to tie in name back to address. So you put owner, then so token ID of the .eth name is actually the integer version of so-called label hash, which is a label is basically if there's a vitalik.is Vitalik part, that's a label, right? And if you hash it, it becomes so-called label hash. Then you tie into integer and the token ID. And what I'm checking here is using ERC721 owner of function. pass the token ID, it passes who owns it, is the owner address, and then I can check that, oh, that's the basically Vitalik.is. That's how you usually use it. Or because we already did it, we kind of turned it into kind of metadata service API. So if you go to metadata.ens.domains and /avatar /matoku.is/meta, it returns all the basically decoded NFT information and also kind of its owner information. By the way, this format is keep changing, so probably by the time you start hacking, it's in a different format. So you should check the actual, but you will see the latest. And we have a lot more features of other, like we have some different API endpoint where it shows the metadata of the basically ENS name itself, and we are working on a doc. Should be available under /docs. And the one fun prototype we have in that project is to overlay ENS name on top of the image associated into avatar field. And this is still very basic version, but maybe for hackathon you could fork this repo and it could go crazy interesting things. Okay, and so this one I'll go very, very briefly, but another way of extending Resolver is for the off-chain support, or so-called layer 2 scaling. That it's good that you can use set lots of interesting information into Resolver, but every time updating it costs lots of gas. So we are working on ways to offload some of the work into layer 2 of your choice. And we recently announced so-called Durin framework. This is a generic ways to retrieve the information from off-chain, including layer 2. And when you get back to the how I explained in the very beginning, is that if you resolving the name is like 2 steps. So first you ask the contract to Registrar to return a resolver, and then resolver return the address. The Durin framework extends a resolver that instead of resolver return the same address, it returns a service URL and the so-called gateway. And gateway is in charge of returning data from layer 2. And if this layer 2 is kind of roll-up model, most of the roll-up should have a ways to verify L2 data in L1 so that the client can verify it. This is still very early stage, and it's not quite ready yet, but we do have some demo of verifying optimism, and we a bit in lack of resource to do. Ideally, we want to basically support all the L2 environment, but it's we haven't done it yet. So one of the hack could be that you look into Arbitrum or Starkware and see how you could fit their L2 into this Durin model. That could be one of the hack. And so the final step is Registrar. I'll go back to the first diagram that, like I mentioned, that there's a registry and resolver, but there is something called Registrar, which is kind of made up terminology representing the ownership of the certain name. So that, like when you register .eth name, it's actually ERC721 NFT. And it's not neither registry nor resolver are NFT. It's actually the owner of .eth is assigned to a smart contract which which allows you to register a new name, which happen to be NFT standard. It's called ETH Registrar. So that's, and for other domains, for example, you probably know that we recently announced that now you can turn your .com address or .xyz, .io, .dev, all the internet domain name into ENS name. That's done by so-called ENS Registrar, that it allows you to submit and claim name if you retrieve the ownership information of the ENS proof, and you submit the proof in another contract called ENS Sec Oracle, and using that information, you can have ENS name of .com, and that's kind of different ways to work. And for testing purpose, you have fast in fast out registrar as well. One thing you could do is creating your own registrar to issue your own subdomain. So for example, if I have matoken.is, you can issue like who.matoken.is. And the prime example is Decentraland. The Decentraland is a kind of virtual metaverse, and when you claim name on their registration page, you can set the name, but that actually also becomes a subdomain of the dcl.is. So I actually do have makoto.dcl.is, and yeah, so as I mentioned, like it can be done by basically setting controller of dcl.eth into their own smart contract. And you can actually look into their source code from EtherScan, and I will briefly go through that. They have something called DCL Registrar, which inherits ERC721 contract, and when it gets deployed, it passes our registry information, and when you register their name, you call registry.setSubnodeOwner, and what this will basically create a subdomain under your domain, in this case dcl.is, and while you do that, you also mint as an NFT, and that's a basic. But one thing you have to be aware that, like, when I repeatedly mentioned in this talk that the ownership of an NFT doesn't, and how you resolve the name are not the same thing. So minting the name itself doesn't resolve. So you also have to set resolver, and then set the ECM address to the resolver. This is the part you also have to do. So this is kind of, yeah, very, very basic of the basically how to create a subdomain on the, also, like, you understand about what other things you can do with resolver beyond just setting ECM address. And there's lots of information, and so I put most of the URL I mentioned in the slide into this part. And also, if you have any questions, I'm happy to answer in the Discord channel. That's it, and thank you very much.